So I've just returned from Braga, which is super interesting because I thought that we had a lot of direct flights to Braga, but unfortunately to Porto actually, not Braga. Unfortunately not, so I barely made it. So you have to take it into consideration that I've just gotten out from the cabin and the airport. So from conference to conference, because in Braga I was talking about industrial revolution, which is a very interesting topic. For the first time, I was actually in a proper factory where a lot of systems like ADAS, cameras, infotainment systems are actually being built, assembled together. So it's mind-blowing to see how things are progressing. And nowadays, when you have a fully optimized chain from assembling things together using cobots, how much data is being produced, it's amazing. And it's a super great opportunity for vision models, for small language models, and other combinations of in between to optimize the process and make it really truly digitalized. But that maybe is going to be my next talk in the future. Today, obviously, it's a very vast topic, and it's only 20 minutes. So a couple of things that I want to talk about. So key challenges, I want to focus on two environments where I've been experimenting heavily with SLMs. Not necessarily going to talk about the projects for the customers I work on, but something that I work on personally and I use on a regular basis just to showcase how the SLMs and VLMs in general, small language model between 1B and 2B, are entering edge devices and supporting a lot of interesting use cases and actually impacting my life directly. I'm going to talk about the second environment, apart from the mobile devices, the one that's very close to my experience and domain is a car. So I'm going to talk a little bit about the car because that's a completely different level of challenge when it comes to deploying this kind of solutions and what they can do. There is obviously much more. I took a little bit the industrial revolution and the factories, but that's maybe the next talk. Okay, so to start with, I think that it doesn't come as a huge surprise that when it comes to deploying this kind of solutions, as opposed to hitting the APIs, Bedrock, Azure OpenAI, GCP, and however you host those solutions using Kubernetes clusters, EC2s on cloud. When it comes to deploying the solutions on edge devices, you basically have hardware as the main challenge. And you think that in general, hardware is progressing and you have much more compute than in the past. But it's very counterintuitive because when you think about the products like car, you can obviously use the heavy GPU and deploy stuff that is 10B plus in the car. But from the price standpoint, it's not going to drive the sales. A lot of solutions like intelligent ADAS and assistance in the car are going to be available to a large group of users that actually buy the cars. So you don't really want to increase significantly the price of the car by bringing a very expensive hardware. So you need to optimize it and actually cut the price of the hardware and the whole solution. So when you get into very complex solutions as intelligent systems based on cameras, vision models, and some behavioral models that need to collaborate together as we're moving towards the software-defined vehicles, then you need to cut somewhere the price. So it becomes, so you're competitive on the market and you can actually sell something to the customers and make it available. So obviously we have quite a few things that we can choose from low-end, high-end, MTUs, SoCs. The amount of possibilities that you have is pretty huge, but you always need to find the one that actually makes sense for a given use case and is, from the price perspective, is also very beneficial for the customers, depending on where you deploy this. However, the best, how I started with SLMs, so but the most interesting, the easiest, let's put it easiest in inverted commas, platform where you can deploy the SLMs and start working with them is your mobile device. I mean, from the standpoint, what it has, it pretty much has it checks all of the boxes from widescreen camera, GPU, CPU, and storage. Everything is available for you. So it's a good starting point to actually deploy this kind of solutions. And there are two providers I wanted to focus on today. One of them being Liquid AI. Anyone heard about Liquid AI before? Okay, good. And the second one is Google, which is also interesting because they silently started to release models that are actually SLMs and are open source. And now I will talk about those two solutions. So starting with Liquid AI, it's a MIT spin-off, and they started something around 2018, but they really started to grow in 2020, 22 and 2023. They introduced something that they call a Leap platform. A Leap platform is basically their tool where you can basically test the models that they build. One point B, I will show you what kind of the models they have, but you can also fine-tune the models. So they have a pipeline that allows you to fine-tune the models. And they also have the applications that are, let's say, a starter pack, where you can take the models and how you have interface ready for you. You can interact with those models. And what is very interesting about the models that they build is that they use a completely different architectural approach. They call it a star architecture, which is based on differential mathematics. So basically they decided, we see a lot of movement in the area of alternative architectures, and they were one of the first ones. They said, we need to try something different. Our focus is 1 point B to 2 point B models, and we're going to use a different architecture. So it's called star differential mathematics, and they use a lot of iterative approach to train their models. Now, what is very interesting from the offering that they have, and this is where it gets really cool, they have highly specialized models in multiple different domains. So they have vision models that span between 2.B, I think that's 2.6B, that's the biggest model they have from the vision models. They also have instruct models. They also have models that excel at maths, and even the models that are optimized for function calling. So think about it. Function calling tends to be problematic for LLMs. And when you take away huge amount of layers and weights and you go to 1 point B, that even gets more difficult. So they have the models fully optimized and fully trained for this kind of structural function calling. And they have several models that you can see here that can be used for extracting 350 million parameters, tool calling, RAG, transcript. So everything that can run on your edge device, your mobile device, or any other device you would like to use. I really enjoy working with their vision language models, and I will show you a couple of demos how I use them on a daily basis and how I tested them. And this one here is very interesting. It's one of the first end-to-end language model, TTS, STT, everything combined together, end-to-end, and I will show you how it works. Hopefully we'll have the voice, so you will see it how it works real life. But that's very interesting because if you think about it, it's 1 point B model, end-to-end, STT, TTS, everything connected, plus generation of voice. And to start, if you want to deploy these models, they also provide SDK, Leap SDK. So basically, you can easily deploy the models in your device as a starter pack, depending on what language you use when you build application in your mobile device. Either Kotlin, Python, whatever works for you. But with Leap SDK, they have the model runner that basically takes the model in the bundle format. So it's a DOM bundle format that you download from their page, you deploy it on your mobile devices, and they basically provide you the model runner, and it allows you to run the model on your device. There's some requirements that you need to fulfill. It works in a similar to Cloud API, but without obviously the cloud provider entirely on the mobile device. Okay, how about Google Edge Gallery? How many of you heard about Google Edge Gallery? None of you? Really? Okay, that's one. Very interesting. Okay, super cool. So Google made 2024. That was the first time when they released Google Edge Gallery. Completely not the way they release other models, right? Like Gemini 3 and some other models. That was somewhere in the background. And I just saw the article, we're releasing Google Edge Gallery. So it's an open source application that allows you to run all of the SLMs that they have, plus some of the smaller models like Gwen 2.5B, but predominantly Gemma 3 models. And one of the most interesting ones that they released recently, and I highly recommend you to play around with this, is a function Gemma. I will show you in a second how it works. So basically, this application you can download from, I think you can download it now from Google Store, or you can download it as APK format. and install it on your mobile device. The way it works, they have some interfaces ready for you, from vision recognition to chats, and all you have to do is connect to your Hugging Face account, use your Hugging Face key, and by connecting to Hugging Face key, you can download those models to your mobile device. And again, they have, I think the biggest model that they have is something around 4.6B, is one of the Gemma models. And again, it runs entirely on your mobile device for free. There is no cost associated with it. That's why a very interesting strategy for Google to proceed this way. But they, as they said, also I saw your reaction that a lot of people knew that they released something like that and is available. So very quickly you can check how those models operate. You can run vision models. You can OCR your documents without necessity to connect to your internet, to your API or any cloud provider. Now, what is very interesting, something that I mentioned, is function Gemma. They released it in December 2025. Also very silent release. It's a 350 million parameter model that's fully optimized for interacting with mobile functions. And the way they released it was also very interesting, because they didn't release it as a model that you could download and just upload to your application. They actually released a Google Colab notebook where you had to fine-tune the model yourself. So they provided a data set for function calling, mobile function calling, and you had to obviously probably pay for, I think I use A100 for this, but you had the full data set. You could explore the data set, or you could augment the data set, whatever you wanted to do this. And basically you could train or fine-tune function Gemma to interact with your mobile device. And I think I can run this. Let me see if it's gonna work. So here is a short demo. So I think they're using a voice, so you have a voice model, but what you can see is actually how this 350 million parameter model interacts with your application on your mobile device. So it's creating events. This is the only activity it's tuned for, right? So you obviously need some orchestrator on the top of it. So it tells the model what to do, but it's fully optimized to interact with, I think in the demo they provided with Google Colab, you could optimize it for Google Maps, you could optimize it for calendar, but you can also turn on and turn off your light to your torch. Maybe not the greatest example, but something that it can do, and some other example. And you can see also how the accuracy goes from the function Gemma base model to fine-tune function Gemma model. Again, if anyone of you would be interested, I can show you how to access the Google Colab notebook and fine-tune the model yourself and deploy it on your mobile device. I said I will show you a couple of demos. So first of all, I need to say that I'm a little bit of a sport freak. So some of the applications I will show you here are pretty much related to that field and what I do on a daily basis. But they show the capabilities of the model. So the first one I wanted to show you is a food tracker that I'm using every day. So every single food I eat is basically I take a picture of my food, and it's using now the 1.6 VL model that is actually using the feedback loop. It's using also the reasoning model, the instruct model, to connect to your SATA database. So the way it works is also it basically takes the image, checks what's on the image, describes it, and then the reasoning model takes it from the VLM and compares it against the USATA. So what you can see here, scrambled egg toast, the analysis over time is pretty good. Typically USATA values and how everything connects. So all I can say is the last 1.5 years, apart from that, everyone is asking why I'm taking picture of my food every single time I eat something. I can say that the quality and accuracy improves significantly. And those are not even fine-tuned models yet. So I'm planning to fine-tune them in the future, but I can already see a lot of value. So very quickly, you take a picture, something valuable that actually impacts my life, but shows the capabilities of really small models that run on your device without hitting the cloud API. The other one is a fitness assistant, again, entirely running on your mobile device without any support. This actually has YOLO overlays. I'm not sure, probably you've heard about YOLO, and it uses the maths model. So what really happens here, there's VLM that is combined with the math model, the YOLO And all of the yellow models, it gives you all of the points where a given part of the body is located. Everything again is run on your mobile device, and you can see it actually recognized the exercise. So you're saying the planche exercise is performed with good form and technique, and so on, and it gives you a score, which is a combination of all of this. Again, running 100% on your device without connectivity to the internet. Okay, and this one will acquire voice. So what I will show you here, it's actually something that I would call maybe future of the DMS, driver monitoring system. So what happens here, usually when you think about DMS, not sure if you know, guys, what is DMS more or less? It's a system which you have in a car and basically recognizes your facial expression to detect drowsiness. So when you see in the car that it says you're being drowsy or you need to take a break, this is the system that actually does it. And the way typical DMS works is it actually has overlays over your face, and it tracks how your eyelids are moving or your facial expression and so on. It can detect your level of drowsiness or any other variables that are associated with it. So what I'm doing here is I'm using only VLM. There is no overlays, there is no YOLO, nothing else. The VLM is tracking my facial expression, what I'm doing here. Behind the VLM, there is an instruct model that is specially trained to interact in specific situation and is trained to call a mobile device and conduct conversation on my behalf. And it uses the voice model that I showed you. This is the 1.6 end-to-end model, STT, TTS, everything combined together. Okay, let's try and let's see if it works. And obviously this is a mock-up. So there is my daughter that will be picking up the mobile and talking with the bot. But yeah, I think it will show more or less what are the capabilities of this kind of solution. So let's see if it's gonna work.
This is an automated vehicle safety system reporting a car accident. Help is needed immediately.
What is the location of the accident?
The accident occurred on Rockcliffe Highway near the intersection with Oak Street.
What is the car involved in the accident?
The car involved in the accident was an Audi A6.
What is the state of the driver?
The driver is not responsive, eyes closed, and breathing heavily.
Okay, yeah, just an example of what you can do. I mean, it blows my mind that what you have here altogether is probably something about 4B, all models combined from instruct, VLM, and audio, and can already perform this kind of interaction with the operator, right? My daughter, but let's call her operator. So I think that future of this kind of system is definitely combination of small VLMs plus the intelligent orchestrators that can run. Okay, one thing, we have a couple of minutes more. So we touched a little bit on how this looks in the car from the DMS standpoint. Another thing is we're moving with the cars in general into the so-called the SDV, software-defined vehicles. So the downside of this is basically you have less buttons in your car and more only big screens, which me personally is very irritating. But I think that's from the cost standpoint, again, it's a very optimized setup. But there is, as a part of this, there is a lot of software being deployed in the car nowadays, right? There's more and more software. And as a part of the setup, they are also bringing intelligent systems into the car. And this is where it's getting very interesting because, as I talked a little bit at the beginning, the hardware constraint, it has a significant impact on the price, right? You want a system that's not very pricey that you can sell for good money, but is also very useful to the drivers. So you have to do actually a lot of things to take those models and deploy them on the target hardware, from pruning, quantizing, and actually training them in a very specific way. We did it in the past. I cannot obviously share how we did it, but I can share an official document that was released by Mercedes-Benz, and they more or less show you how this is being done. It's very interesting the way you prepare the model for function calling in a car. So what you see here is they give specific examples what the model needs to do. So warm my seat and set the mode to some ambience and they specifically map the functions to this lower signals in the car. So you can actually understand how you can interact in the car. What is very interesting is in the queries or in the setup, how they fine-tune the model to interact with the lower signals in the car, like opening the windows, increasing the temperature and lowering the temperature, and so on, is that they also provided negative examples. And some of the negative examples were interesting. They were saying, like, the negative example would be transfer the car to New York in 1 second. So that's how they provided negative examples to reduce, any potential of hallucination and responses that are not aligned with the signals in the car. And I feel like if I take a look at the future, so definitely you get into your car, it will know you. There will be a hybrid architecture between edge, voice command, STTTS, and an intelligent model that can interact with lower signals in the car and tell you what you're seeing, what you're doing, changing the temperature for you. There will be definitely some connectivity to the cloud. We also tested it. So for some much more difficult tasks like booking, for example, places at the restaurant, your preferred restaurant at a given date, so it will have to interact with cloud. So this is kind of a cascade architecture. But from what I've seen so far, I had a couple of demos where they were a little bit mind-blowing, that the model could already open the spoiler for you during a ride, and that was pretty amazing. And I feel like what we'll see in the future and what could be a good idea, or maybe breakthrough idea, would be probably something that we've seen for iPhone. Like, when iPhone was released, it was revolutionary, right? But the sales were not driven by the iPhone release. The sales were really driven by what happened 1 year later, and that was actually the store that they released and all of the application that you could build. So I feel like this could be revolutionary for agentic systems in a car when you think about having the store where you can actually build the applications for your car that are specific for your car, for your needs, for your activities that you do as a part of the routine when you drive a car, and also unified layer, maybe an MCP, Model Context Protocol, for cars in the future. That could be very interesting to see. Okay, we saw the use of the model from Liquid AI. One thing that is very interesting, and maybe just to close from where we're moving with, in general, with intelligent cars and small language models, is Alpamayo. Have you heard about Alpamayo? Okay, give it a go, because this is generally where we're going with the VLMs. This is the representation of the so-called vision language model. So as opposed to VLM that does the image recognition and description of what it sees on the image, the VLAs can also perform certain activities. So what you're seeing here is very revolutionary, because Nvidia released that at the beginning of the year. They announced it at CES in Vegas. And as of now, it's a 10B model that can perform certain activities in closed loop, meaning that when you drive a car, it can use the vision for multiple camera angles, understand what's happening, and perform activities such as stopping the car. Like, there's a kid running out on the street. So it uses the visual component, the reasoning component, to take a decision in a closed loop. Okay, I need to stop the car because there is a kid on the road. For now, this is a 10B model. They also have 0.5B model that is not released yet. They also have very interesting data sets, in general, 89 terabytes of data that they released in AlphaSim for the simulation. But when you think about the future, on where we're going with these vision language models that can not only understand the visual, but they can perform the reasoning and activities. This is like when I initiated with industrial digitalization, robotics, cobots, and so on. This is the perfect area where those kind of solutions can be deployed. Not only anomaly detection, but also reasoning and action to be performed based on the anomaly detection. So I highly recommend to read about NVIDIA Alpamayo and some other models that they released in addition, like NVIDIA Cosmos 2 and NVIDIA Cosmos Transfer. Those are showcasing the real capabilities of the VLA and what comes next. They also, it's a 10B model as of now, and there's one point being that they also want to release. Okay, I feel that I hit. So the last thing I just wanted to show you what I discovered recently, and what also showcases that we're moving towards efficient small language model is FGen, and I actually discovered it yesterday. It's a first agentic framework. So think of this LangChain or any other frameworks that is fully optimized for 1.b models. So it has prompt compression, it has memory optimization, it has all of the features that enable 1.b models to run on your device in an agentic way with full optimization. So I think it's a great indicator that what Nvidia said, I think it was Jensen who said it some time ago, that SLMs are the future of agentic systems. And I think that's a pretty good indicator of where we're heading with them. Thanks a lot, guys. And if you have any questions or you would like to stay in touch, just let me know. Happy to share any additional info. Thanks a lot.
Right. Some questions?
Hi, great talk. Thanks for that. So for someone who is used to orchestrations and things like that on the cloud and whatnot, and who wants to dabble in this, how do you you said earlier that you can have orchestration with some of the fine-tuned stuff there. How do you mix them together? How would one start to use their own orchestrator, but combining with the SLMs and things on the device, for example?
Listen, the best way is to start with, do you have anything that actually requires running those things on the device?
Purely interest.
Pure interest. Okay, what I started with, I think that's take a look at FGen in the first place, because you can run it on your laptop, and it already gives you a possibility to take all of this together. Because in the past, when I used to devise those solutions on my mobile device, I had to think about it and code it myself, right? There wasn't really a framework in place that I could use. Now you have this framework in place that answers or covers a lot of the bases, all of the topics that are important for setting up an agentic system. And then whatever you use behind, you can start with liquid AI models and deploy them using the LLMday SDK, which will significantly speed up the build of the solution. But I think this is open source. You can go to GitHub, download it at any point, and already you can start experimenting and building this solution. You can start with building OCR. There is when OCR2, for example, when you take an invoice, it's OCRs the invoice, and then you can have a agentic system, upload it to database, do the sanity check, and then update the dashboard or change the status, something like that to start with. I think would be good. But yeah, I think that's a good starting point. You already have framework in place that you can use to build your solution, no matter what the target use case will be.
Yeah. How would you say connect that to, let's say this was almost like an IoT-ish type standalone with its own intelligence, and you wanted to combine it with something else of intelligence for them to communicate? How would it communicate with the system, for example?
It supports all the protocols that are right now.
Okay.
All of the protocols are there, so you can take them and use them and connect to whatever you want.
Nice. Thank you.
One more? All right. Thank you.
Thank you.
All right, folks. So it's a wrap for this track, as far as I know. Thank you so much for being with us today. It was a pleasure. There will be still one more session in track 1, I think. So yeah, I hope to meet you soon and keep in touch. Appreciate it.